find the midpoint of each row line, so it's just like the beginning of the year. For the first one, you could take -4 plus 6, your two x coordinates, add them together, divide by 2. So -4 plus 6 is 2, divided by 2 is 1. So that's our x coordinate of our first midpoint. And then 3 plus 9, our y, is divided by 2. 3 plus 9 is 12, divided by 2 is 6. So our first coordinate should be 1, 6 at the midpoint of AB. If you haven't already finished, or see if you can try and finish the midpoint of CD. See if you can get that one. All right, what did we find for the second midpoint for CD? 5, 0. So -3 plus 13 is 10, divided by 2 is 5. 7 plus -7 is 0, divided by 2 is 0. The 5, 0 is our second midpoint. We okay with this? Cool. So I was like midpoints earlier. But why are we doing midpoints? We're talking about triangles. So today we're going to talk about the mid-segment of a triangle. So we're going to learn what are some special properties that mid-segments of triangles have, and what is the mid-segment theorem. But in order to figure out what a mid-segment is, we need to find the midpoints of our triangle. So we need to get the midpoints of our triangle. So every side of a triangle can have a midpoint. So with this triangle, we can have 3 midpoints because we have 3 sides. So in order to find the midpoint of a side, we can look what are the coordinates of that side. So I'm going to do x and y. So x is 0, 5 is the coordinate. Y is 2, 1. So in order to find the midpoint of this, I'll use 0, 5 and 2, 1. So 0 plus 2 is 2, divided by 2 is 1. 5 plus 1 is 6, divided by 2 is 3. So 1, 3 is the midpoint of that side. So I can go 1, 3, and that puts me at the midpoint of my triangle. I know it's on my triangle, so that's good. So see if you can do that exact same thing and try to find the midpoint of xz and yz. So z is -4, 1. See if you can use those coordinates to try to find your other midpoints. So we hopefully were able to get those other 2 midpoints. So we should have had -2, 2, and then -1, 0 was our third midpoint. Are we okay with this so far? So we have our 3 midpoints. So today, or this week, we've been talking about triangles. So we learned, on Monday, we learned all the angles of a triangle add up to equal 180. We learned that the exterior angles of a triangle are equal to the opposite 2 angles. We learned yesterday that isosceles triangles, if you have 2 sides that are congruent, you have 2 angles that are congruent, and vice versa. 2 angles means 2 sides. So today we're going to learn about the mid-segment of a triangle. And what the mid-segment of a triangle is, if you have 2 midpoints of 2 of your sides of a triangle, and you connect them, that creates a mid-segment of your triangle. And some mid-segments of a triangle, they can have some special features. And that's what we're going to try to figure out today. What are those special features out of this segment? But a triangle can have up to 3 mid-segments. Because you have 3 midpoints, I can make a mid-segment here. I can make a mid-segment here. It doesn't matter which ones you connect. These are all counted as mid-segments. As long as there are 2 midpoints connected, it makes a mid-segment. I'm going to keep with just my first one I have, just for the sake of convenience. That way we focus on what can we find about this one, and then we'll talk about how it relates to the others. So, just by looking at it, what can you assume, or what can you guess about this mid-segment? It's inside the triangle. Okay. It makes a new triangle. So we have a little baby triangle up at the top compared to our smaller or our large total triangle. Okay, all of our vertexes are still on the original triangle. What else? So YZ, it's not touching any side of YZ. Okay. Think about some things that we've talked about so far in geometry this year. What are some things we've talked about? Do I get that? Well, actually, it is like a smaller version. When we get to similarities of triangles, we'll talk about things like how they relate to geometry. But we won't focus on that today. That'll be a little That is something to keep in mind. What else do you notice? Two weeks ago, we talked about equations of parallel and perpendicular lines. What do you notice? So they look parallel. How can we figure out if they actually are parallel? So we don't have to do proof. What determined whether a line was parallel to something or not? What determined whether something was perpendicular or not? They had the same slope. So if two lines were parallel, they had the same slope. So if we look at the slope of my midsegment, I go up 1 over 3. That's my slope. Well, so that would be if you're perpendicular to a midsegment. Let's see if it's parallel to this other point. We have to see if it's. I'm going to go between these 2 points. That's up 1 over 3. Ah, interesting. So they both have a slope of 1/3. So that means our midsegment is parallel to our base, or to our opposite side, YZ. If you were to do this midsegment, it would also be parallel to XY. Or if we were to do this midsegment, it would be parallel to XZ. It's always going to be parallel to that opposite side, the side that it doesn't touch. That's one cool fact about a midsegment that we'll talk about. What else do you notice? We have one other thing we can find out about midsegments. What do you notice about the size of the midsegment? So if I were to look at this total length of YZ, dy, I'm going up 1 over 3, and I'm doing it again, up 1 over 3. So in a sense, I'm going up 2 over 6 is like the total distance being traveled on this bit, or on that YZ. On my midsegment, I'm going up 1 over 3 is the sort of total distance that's being traversed. What do you know about that? It's going to be half of the larger one. So if we were to use our distance formula that we learned about, we could do change of y over change of x squared, or x2 minus x1 squared plus x1, or y2 minus y1 squared, take the square root of that whole number. That would give us the distance of this midsegment. We could find that out. We could do that same distance with yz. If you solve for both of those, we'll actually determine that the midsegment will be half the total distance of yz. And so your midsegment will always be half the length of your opposite base. So once again, if you were to create this midsegment, it would be half the length of xy. If you were to create these two midsegments, it would be half the length of xz. What was that? Yeah, it's something, it's one of our theorems that we'll talk about. It's something that's going to work for every triangle. And so we can kind of see this in action, actually, on this, if I can pull up. So the numbers might be kind of hard to see for some of you. But if we look, I have the length of my midsegment, and I have the length of all my bases. Here's the length of the midsegment, here's the length of the base that corresponds, length of the midsegment. And we notice right now, they're all, I know the numbers are rounded, but they all should be 1/2. And it's 1/2. But it doesn't matter which way I move my triangle, 7.9 is still 1/2 of 15.8. 19.9, half of that is still 9.95. 10.76, half of that is still 5.83. It doesn't matter which triangle I make, I can move my triangle all around, it's still going to get that same halves for my midsegment. So no matter what triangle I have, any midsegment will always be half the length of the base. So that's a cool feature. Looking at this triangle though, we're looking at the angles. So I see my angle down here, 52.06, that's the same as 52.06 up here. 65.89 is the same as 65.89. These are corresponding angles if we think back to our parallel lines. Because these two lines are parallel, those two angles should match. If I move my triangle any way, those angles are still matching. It doesn't matter where I move my triangle, we'll still get matching angles for that no matter what I end up with. And that's because of our midsegment always being 1/2, or always being parallel. And so we'll have those correspond. So these are the two main things to remember about our midsegment. Anytime you form a midsegment, anytime you have two midpoints in connected, form a midsegment, it's always going to be parallel to the base of that triangle, and it'll always be half the length of the base. Once again, the base doesn't necessarily mean the bottom of the triangle, it just means the opposite side of where that midsegment is formed. And so you could have a midsegment like on this one, you could have a midsegment that comes back to me. We could have a midsegment right here, and this would be our base. So it's not necessarily the opposite of what's going on. All right, so these are the two things we want to focus on. So parallel, it's always parallel to the base, and it's always half the length of the base. And we can use these two rules, or this theorem, to help us solve for some situations. As long as we have those midpoints, and as long as we have that midsegment, we can use this information to help us solve for some information. Just like using an exterior angle, or just like using isosceles triangles, we can use them to help us figure out missing angles or missing sides. So let's say we have these two triangles. So on this first one, our goal is to try to find the length of this midsegment and also to find what that variable x is. So using our knowledge of midsegments, we know the midsegment is always going to be equal to 1/2 that base. So whatever the length of this midsegment is, for now it's 3x minus 1, that's equal to half of the length of my base. 1/2 of 34. Do I know what 1/2 of 34 is? 17. So I know my midsegment is equal to, the length of this is 17 units long. One piece. If we were to solve for the second piece of information, we're trying to solve for x. Two-step equation, add 1, that gives me 3x equals 17. Sorry, 18. Then add 1. Divide by 3, and we get x equaling 6. So we know x, 6. If we were to plug 6 back into that equation, 3 times 6 is 18, minus 1 is 17, which matches what we said earlier. So we know it's right. And so you can use that knowledge of the midsegment being half the base to help you solve for this. Are we okay with this first one? Okay. So looking at this second problem, we have an expression for our midsegment and for our base. So we don't know what the value of either of them are. So we can't just say the value is 7, or it's equal to 17 like we did on the last one, but we have to. What we do know, though, is that our midsegment of 4x minus 2, that's equal to 1/2 of our base. So 1/2 of 5x plus 3. That's what, based off of our knowledge of midsegment, that's what we have so far. We know that midsegment is equal to 1/2 of that base because of what we've learned earlier. There's a couple ways we can go about solving this. One, you could distribute that 1/2 into your function or into your expression and then solve your equation that way. Or we can try to inverse this 1/2 and get it over to our other side. Personally, I like moving the 1/2 over. I don't like distributing by a fraction. It's not as fun. Get some funnier numbers. We're going to have like a 2.5 and a 1.5. Wait, that's right now. So if I want to inverse this fraction over to my left side, what's the inverse of 1/2? 2/1. So if I multiply by 2/1, that cancels out my fraction of 1/2. Because anytime you multiply by a reciprocal, it cancels the fraction out. But if I multiply one side by 2, I have to multiply my other side by 2 as well. That means 4x minus 2 is going to be multiplied by 2. 2/1 is the same as 2, so I'm just writing 2 because. So we can distribute this in just as we would. So 2 times 4x means 8x. 2 times negative 2 means 4. And so we have 8x minus 4 equals 5x plus 3. Remember, if we're multiplying one whole side by 2, that means I can multiply everything on my left side by 2. So everything is being put in that parenthesis. Not just the 4x, not just the negative 2, but it's all being multiplied by 2. From here, we have a multi-step equation that we can sort of solve. We need to get all our x's to one side, all our y's to the other. So I'm going to add 4 to this side. Which gives me, or you could subtract 5x. So I have 8x equals 5x plus 7. And I'm going to subtract 5x. Really doesn't matter what order you try. So that gives me 3x equals 7, which is going to give us an ugly number, but we'll work with it. Divide by 3, divide by 3. That leaves me with x equaling 7 over 3. That is 2.33 repeating. I get it up here, but that's okay. We can do that. So that's what x equals. But in order to actually find the value or the length of that midsegment or the length of that base, we're gonna need to plug that in. So I'm gonna go up here, and I see 4x minus 2. So I'm gonna plug 4 times 2.3 because that's my value of x minus 2, and I can figure out what the length of this midsegment is. So 4 times 2.33, that's roughly 9.33. That's 9.33 minus 2 equals 7.33. And that is the length of my midsegment. We can plug 2.33 in for x as well, and that can give us our base. Or we can just think my midsegment is half of my base, so I can just double this number and not give my base. So double 7.33, and that gives me 14.66. And that would be equal to my base. So anytime you have a little bit of information about the midsegment and that base, you can use that together. You can all of them being one half of each other to be able to solve for those missing sides. And that can help you solve for some other information down the line as well. Are we okay with this so far? Questions, concerns ever about the length of midsegments? So that was one part, but we talked about two things about midsegments. So the length of the midsegment was one thing. The other thing was the fact that they're always parallel. So when we start dealing with parallel lines, we can think back to what we've talked about before. When we have parallel lines, that means we have parallel angle pairs. So our alternate interior, alternate exteriors, corresponding, consecutive. We can use those now that we know we have parallel lines. That needs to be double hashed. So here I have two triangles. I see that this side length and this side length are the same. So that means this is a midpoint of one of my triangles. I see this same length is the same as this. So that makes this a midpoint of my triangle, meaning this is a midsegment. If that's a midsegment, I know that these are parallel to each other. And we can use that information to help us solve. So we need to find some missing angles. So currently I am looking for angles A and B of this triangle. Are you okay? You just gave it for me. I'm looking for angles A and B. Can I solve for any of these angles at the moment? Is our knowledge of triangles so far? $45 for what?
On the other side.
Right here? How do you know it's 45? So these will be corresponding angles because we have parallel lines. So that would make that 45 as well. They're congruent. Good. Not one of the angles we're looking for, but it still helps. No. Can you find anything else? Not necessarily. Because B is formed by these angles, these two lines, while 100 is formed by this one. So this line might be the same, but these two lines are not parallel. And so that wouldn't be confusing. But looking at if I look at this whole triangle, the large triangle as a whole, I forget I have a midsegment. I have 100, I have 45, and I have a missing angle. Can I solve for that missing angle? How?
35.
I can do 180 minus 100 minus 45, and that leaves me with 35. So 35 is A. Okay. What else can I figure out about that? Let's find B. Would B also be 35? Is that right? Not quite, because if we look, B is a much lower. I mean, we shouldn't always look at the picture. We shouldn't always assume from the picture. But B is an obtuse angle in this case, and it's going to be much larger than that. If we look, these two lines are parallel. These are knowledge of parallel lines. So I have two lines that are parallel. I have a transversal. What does that make A and B? They're consecutive angles. If we were to think about extending these lines out to sort of make the intersection, make it more visible, we have these intersections. These are same side interior angles or consecutive angles, meaning that they're going to be supplementary to each other. So if this is 35, we can find B by 180 minus 35, which should give us 145 degrees.
Could you just add 145? Or they're just in this case?
Yes, you could. So we could see another thing you could use using other pieces of our information. We have this small triangle in here.
That's what I'm saying.
B, is that what you were saying about the exterior angle? Sorry, I didn't catch that. So B is an exterior angle of this small triangle. We know exterior angles are equal to the two opposite angles of your triangle. And so 100 plus 45 equals 145. So, sorry, Gage, I didn't catch on to that. But no, that's good. That's it. So we're using all of these different tricks. And so there's multiple ways you can solve for these things, because we have multiple theorems and multiple methods of being able to. Well, we found A and B. Good job. So with this one, with this second angle, or second problem, we want to try to find A, B, C, F. We want to find all of those missing angles. The only thing we know so far is 56 and then those side lines. That's all we have. So what can we do to help us? Why is A 56?
Because the side length is better for 8.
So we look, this triangle, if we add both of those side lengths together, that's 16. If I add both of these side lengths together, that's also 16. If I have two side lengths that are the same, it's an isosceles triangle. And we learned yesterday, isosceles triangles, those opposite angles have to be congruent. So if this is congruent, then that means A must be congruent as well. So this also has to be 56. So good. We have A. For what one?
B. C.
So, what line is this? Mid-segment. The way we know that is because this side is 8, this side is 8, so that makes this a midpoint. This is 8, this is 8, so that makes that a point. So we know it's going to be parallel to the base. So if we have parallel lines, what does that make 56 and B?
Supplementary.
Supplementary, they're going to be consecutive angles. So if this is 56, we can solve by 180 minus 56, and that will give us our B. 124, I think. Same thing with C. You could say A and C are supplementary. If this is 56, you get 180 minus 56. Okay, so this is another 124. What about D or E? Can you solve for those? So they'll be supplementary to their adjacent angle, or you can think of that they're corresponding to their bottom angles, so they're congruent that way. So these will also be 56. Can you find F? So 180 for the whole triangle minus 56 minus 56 gives us f, which should be 68, I think.
These are painful.
Painful. So it's really being able to recognize what tricks you're able to have. Like, what is your toolbox? How can you use those to help you assist? So we have a couple different tools. We know all of our angles of a triangle add up to equal 180. We know that exterior angles are equal to those two opposite angles added together. We know isosceles triangles have those congruent angles. We know mid-segments have parallel lines, half the length. So we're using all these different tools to help us solve for those missing pieces of information, help us create those equations, and help us use the algebra to solve. And so basically, the main strategy is just being able to recognize when should I use which, or when should I use all of these angles, or when should I use my exterior angle, or what situations it's being put in front of me. What do you recognize? So the main challenge that I really want you to focus on is just being able to recognize when you should use which one. When should I use exterior angles? When should I use isosceles triangles? And be able to recognize when those situations come up so you can be able to then solve with them. And so that's what we're going to focus on tomorrow. The main thing is, so we learned all these 4 different theorems about triangles. So tomorrow we're going to focus on being able to utilize these theorems. So given a triangle, okay, look through it, okay, I see these two side lengths are the same, so I know it's isosceles, so I can use my isosceles base angle theorem to figure out some angles. And so we're using those different angles to help us solve for these missing pieces of information. So it's not necessarily I want you to be able to say, like, okay, what is your base angle theorem? Write it down. I want you to be able to utilize them, but I won't necessarily tell you use the base angle theorem to solve this. I'll give you a problem, give you a triangle, and say, find the missing angle, and you're going to have to think, okay, what tool should I use to help solve that problem? And so it will be hard. It will be difficult to think of, to cycle through which tool should I use to fit for this problem. But that's how it's going to be on your state test. They're going to give you a problem. They're expecting you to think through all of that stuff you learned through geometry, and they're expecting you to think through and pick, okay, I want to use this piece to help me solve this problem. And so you will have to think a little bit more. You'll have to think critically. You'll have to problem solve, but you can do it. You're building yourself up, and you're becoming a better student because of it.
We're going to have one more day than we do.
We'll have Thursday of reviewing. We'll have a bit of Friday, and then we'll have our quiz Friday. We'll